So part B of number 2 asks us to find expressions as functions of time for 3 different quantities. The first one is momentum. So we know momentum is little p, and the formula for it is just mass times velocity. And the problem tells us the mass of the truck, that's just a constant, it's 2,000 kilograms. But then v, velocity, changes with time. And so we're actually going to put the function for velocity in there. And you should have that function from doing part A, but you're just going to get it by taking the derivative of the position function with respect to time. And so you'll multiply that by 2,000. That'll give you your momentum function. Then for part 2, it's going to be kind of similar. This one asks for kinetic energy as a function of time. So the formula for kinetic energy is 1/2 mv squared. So again, we know the mass is 2,000. And then velocity is a function of time that we're going to plug in for v there. And we get it by taking the derivative of the position function. And then we just have to remember to square that function when we plug it in. So that'll give us kinetic energy. And then for part 3, it asks for the power being delivered to the truck as a function of time. So we use capital T for power. And power is the rate at which work is done, or we can also think of it as the rate at which energy is transferred. So it's the rate at which energy is actually being delivered to the truck. And we have an energy function. That's our kinetic energy function that you got up here. So really all we have to do to get the power function is just take the derivative of the kinetic energy function. We're not dividing kinetic energy by time. We're taking the derivative of it with respect to time. And it will probably be easier to take the derivative if you first simplify your kinetic energy expression. So I would simplify it algebraically as much as you can, and then just take the derivative of each term, and that'll give you your power as a function of time.